My name is Lisa Madison Smith, and I'm Professor of Biological Anthropology at the University of Otago. So today I'm going to be talking to you about kind of who are we and where do we come from, and in particular looking at this question of understanding human migrations and understanding how people got to Aotearoa, New Zealand, and from the first people who arrived here 750 years ago or so, to the people who are continuing to arrive as we speak. So traditionally, when we look at and think about human evolution, we would look at fossil differences or fossil remains of early hominins and how we can trace our ancestry back, the origins of our species, Homo sapiens, back to Africa. But we can also look at where do we come from a number of different perspectives, from talking to your parents about literally where did we come from, where were our grandparents born, where did we have, what is our culture, but we can also look at our DNA. And the first person to really use our DNA to understand where did we come from was a New Zealand researcher, a man by the name of Alan Wilson, who was born in Aotearoa in the north of New Zealand and studied at the University of Otago, and then went off to do his PhD in the United States. And what Alan did was said we can use our DNA. We all carry our ancestors with us in our DNA, which we inherited from our parents, which they got from their parents, and so forth. And so we can actually work the other way around. Rather than working from the past to understanding where we are today, we can reconstruct our past by looking at the genetic variation that we see today. So we don't know if all of those fossils had descendants, because many of them didn't, but we all know that we had ancestors, and so we can work backwards. So that was quite a different way of thinking about human history and using our DNA, using the differences and the similarities in our DNA to reconstruct the family tree. And Alan and his team, his students at UC Berkeley, published some really, really important papers about tracking human migrations through DNA. And in particular, they looked at one part of the DNA, a DNA that's passed down through the maternal line, from mothers to their children, that you inherit only from your mother. Most of your DNA you inherit from both of your parents, and so you might look a little bit like mom and a little bit like dad, but this mitochondrial DNA you only get from your mom. And so it makes it a really nice tool to cleanly trace family histories, kind of like you might be able to track your last name and understand your family history by looking at all of the people who share the same last name as that you have. So what Alan Wilson and his students published in 1987 was a theory that's known as the mitochondrial Eve theory. And what they showed by looking at the mitochondrial DNA from people from around the globe was that we could trace our ancestry, all of us, all modern humans, could trace our ancestry back to Africa, back to a single maternal lineage, or a lineage that was carried by women that lived in Africa about 150,000 years ago. And that all populations then could not only trace their ancestry there, but trace how those ancestors moved across the globe to reach the places that we see people living today. So that mitochondrial Eve, as we say, was generally traced to East Africa. But we can look at the mitochondrial DNA and the differences in our mitochondrial DNA and start to look at differences in different parts of the world and see how similar and how different the mitochondrial DNA of people are. And we can start to then use those DNA differences and those DNA haplogroups, or the branches of the family tree, which we give a letter to, where do we see those different branches? And then we can start to reconstruct actually how people moved and when people moved into those places. So we can see, for example, there's not so many lineages in the Americas or in the Pacific region, and so we can trace where did those lineages that we see. We see mostly B lineages in the Pacific. Where did the B lineages come from? Well, we can see that they came from East Asia, and then we can link those back all the way to the common ancestor who lived in Africa. So reconstruct the family tree using our mitochondrial DNA. And what do we know about that? Well, we know people left Africa about 65,000 years ago and began dispersing across the globe. Some people went north and into Europe about 40 to 45,000 years ago. Some people came south and into Australia and New Guinea and out into the Pacific. Some people went across to Asia, and then of course people went across to the Americas as well. So we can start to reconstruct these pathways, in a sense, by looking at the DNA that we carry. So when we're looking at the settlement of the Pacific region, we're one of the first populations that came out of Africa. We have archaeological evidence of people arriving in Australia and New Guinea about 50,000 years ago. So it only took them about 10,000, 15,000 years to get all the way from Africa through southern Asia and into Australia and New Guinea. And one of the things you have to remember is at the time that they're doing this 50,000 years ago, or 50,000 years before present, BP, that's 50,000 years ago, much of the water in the oceans was actually sucked up in the poles because we were in an ice age. And so when the sea levels are lower during the ice age, these islands, for example, what is now island Southeast Asia, were joined together to a very large landmass. We call this Sunda. And Australia and New Guinea and Tasmania were all joined together in a landmass that we call Sahul. But these islands here in island Southeast Asia were always islands. There was always water barriers there. So people could walk all the way from Africa to here, but they had to get across these water barriers, and they had to use some kind of watercraft, canoes or something, to get across in order to arrive in Australia, the greater Australia New Guinea Sahul continent. And as I said, we have archaeological evidence of people here 50,000 years ago, and by 45,000 years ago, they're throughout Australia. Now, about 10,000 years ago, those ice sheets melted and the sea levels rose fairly close to where they are today. So we see a separation between Australia and New Guinea, and Tasmania is up here. New Zealand separated a long time ago, 60,000 years ago, or sorry, 60 million years ago. So, but this area of very early human migration, New Guinea, Australia, as far as the Solomon Islands, people were out in the Solomon Islands by 30,000 years ago, so very early. The settlement of beyond the Solomon Islands, an area we call remote Oceania, doesn't happen until very, very recently. So this is one of the earliest out of Africa migrations. The settlement of near Oceania, this region here, but the settlement of remote Oceania, including New Zealand, was very, very late, and in fact it was one of the last major human migrations. So the settlement of remote Oceania had to involve watercraft. We're talking about people traveling major distances across oceans to reach the islands of remote Oceania. Now, one of the things that's really interesting is when people are sailing across the Pacific and sailing out to the islands of remote Oceania, including New Zealand, is that most of the time they're sailing into the wind. This is quite difficult to do. So, surprisingly, when we start looking at the archaeological evidence, we see that this expansion into remote Oceania happens very, very quickly. And that tells us that somehow these people had figured out a very safe way of going out and exploring the Pacific and coming back for return voyages. And then once the exploration voyage has taken place, they can then take colonists in their canoes and they know where they're going to. So we see a very systematic and planned settlement as people move across the Pacific, sailing into the wind, which is the hard part. Then when they find land, they sail back with the wind blowing them back to the location that they know is their home. They're basically navigating using the stars, and they had very, very sophisticated boats and sailing technology. So this means that there was probably very little loss of life, that people weren't just pushing off the beaches and hoping to find land, dying at sea, which is what a lot of people thought about the Pacific settlement for many, many, many years. So there was a difference, we think, between people exploring and finding land, then going home, and then taking settlement people with them. So difference between exploration and settlement. So the earliest people who we see going out into the islands of remote Oceania have a unique culture, a very identifiable culture. And we identify that as the Lapita culture. And sometimes we refer to the people who carry this culture as the Lapita people. And we identify them archaeologically by their pottery, but also by the tools and the jewelry and the ornaments and the things that make up their culture that we see in the archaeological record. And of course that also includes some of the foods that they ate, the plants and the animals that they carried with them. So Lapita sites, these archaeological sites, first appear in New Guinea, in the islands just north of New Guinea, in the Bismarck Archipelago, about 3,350 years ago. And they reach Vanuatu by about 3,000 years ago, and they get all the way out to the edge of the Polynesian Triangle. Now this is a reconstruction of a very important archaeological site in Vanuatu called Teuma, that is one of the earliest and largest Lapita archaeological sites that we have in the world. So this is an example of the Lapita pottery, the decorated pottery that these people were making. Sometimes we talk about, technically it's referred to as dentate stamping, or using little tooth-like tools to make these designs in the pottery. It was very much like tattooing, the way that people are tattooing traditional tattoos in the Pacific today. And some people have suggested that maybe they were actually tattooing their pots and expressing their culture in the designs that we see in the pots. And these designs that we see in this pottery that's 3,000 years ago are very, very similar to the designs that we see in Pacific tattooing today, the designs that we see in tapa cloth, for example, today. So we see kind of this continuity of culture through time. So if we look at this map, this shows how we see, where we see Lapita archaeological sites. So the earliest ones occur here in the Bismarck Archipelago, this New Britain and New Ireland, about 3,350 years before present, 2 years EP, years ago. They reach Vanuatu and New Caledonia about 3,000 years ago, and they reach Samoa and Tonga about 2,900 years ago. Now, all of the people who settled this region, these Lapita people, speak very closely related languages. And we refer to these languages as the Austronesian languages, and in particular, this yellow group is the Oceanic subgroup of Austronesian languages. So somebody who lives in Samoa can actually be talking to somebody who lives in New Guinea and the Bismarck Archipelago, and they can understand each other. There's some differences, but they're very, very closely related. Similarly, somebody from New Zealand speaking New Zealand Maori, speaking to somebody who speaks Hawaiian, they're very, very closely related languages. All of these languages, these Oceanic languages, belong to the Austronesian language family, and we trace the origin of the Austronesian languages to Taiwan. So many of you will have heard about the out of Taiwan hypothesis, that Polynesians came from Taiwan. That's based on the languages that they speak. They all speak similar languages. And I'm amazed when we count, for example, in Maori, Tahiro, Toruwha, it's the same terms that they use for the languages and islands that I'm working on in New Guinea. Similarly, the term for I, mata, is the same. So we have the settlement of remote Oceania by the Lapita people. They reach the edge of the Polynesian Triangle, but the expansion stops there. We don't know why the Lapita people don't continue further, but it's another 1,500, maybe even 2,000 years before people move out into the rest of the Polynesian Triangle. And we have the settlement from Samoa and Tonga, moving out to the Society Islands, that's Tahiti, for example, through the Cook Islands, about 1,000 years ago, maybe 1,200 years ago, and then they move up to Hawaii, out to Easter Island, Rapa Nui, and down here to Aotearoa, New Zealand. This is the last landmass that's settled by people, and people reached New Zealand 730, 750 years ago. So the Aotearoa is the last landmass. Now what's really fascinating, and certainly even when Captain Cook arrived here in 1778, he recognized that the languages of Maori and Hawaiians and Tahitians and Samoans were so similar, and they looked very similar. He said, how shall we account for these similarities over this vast ocean? And that's, due to the common ancestry. But Europeans didn't really appreciate that at the time. They thought, how could these people, get across these great distances? And sometimes we forget how huge those distances are. So if we look at this is a map of French Polynesia. So here's Tahiti and the Marquesas Islands up here, the Austral Islands down here, and this is put over a map of Europe. So here we have Spain, here we have Britain, here we have Scandinavia, here we have Eastern Europe. So just French Polynesia takes up all of the European continent. And we think Europe is really, really big. And really, this gives us an appreciation of the distances that those ancient Polynesian voyagers traveled. Because what we're talking about there is just this circle here. So 3 times that distance is how the Polynesian ancestors, how far they traveled across the ocean in order to reach the islands of Polynesia. So it's a pretty impressive event in human history that required an amazing technology and knowledge and skill of navigation and science, really, not necessarily science as you might be studying it in the books, but these voyagers, these navigators were truly skilled scientists. Now, as we say, the Lapita people and their descendants, the Polynesians, carried their important food items with them, as we all do. We keep our culture with us, and we have our favorite, whether it's Italian food or French food or Pacific food. They carried their pigs and their dogs and their chickens with them when they settled the islands. And we realized we could actually look at the genetics of these animals to reconstruct the voyages that people took over time. And so we studied the DNA of the rats, we've been looking at the DNA of the dogs and the pigs, and in the same way that they were reconstructing human migration pathways using human mitochondrial DNA, we've been doing that with the animals as well, to give us another picture of how the canoes that people brought these animals in, where did they come from? Where did the New Zealand rats come from, the New Zealand dogs, for example? And so what we found was that the Pacific rats, or the kiori as they're known in New Zealand, from New Zealand are coming out of the Cook Islands and the Society Islands. And similarly, the Hawaiian rats are also coming out of that same area. And ultimately we can trace these rats back to Samoa and Tonga, and ultimately we can trace those rats back to island Southeast Asia. So there's lots of different ways that we can trace kind of the movement of people and their cultures across the Pacific. When we look at the mitochondrial DNA of the humans, in Polynesia, amongst Polynesians, the most common lineage, mitochondrial lineage, is haplogroup B, and we see these various sub-branches of haplogroup B that came out through East Asia, through island Southeast Asia, and ultimately reaching the extremes of the Polynesian Triangle. We think also Polynesian voyagers possibly got over to the Americas. We don't see any of their DNA there, but we certainly do see some of the animals that they carried with them. So when we look at the haplogroup B lineages as new changes in the DNA accumulate through time, we see a full range of lineages, of branches of the family tree that we are labeling with different numbers and letters in Maori today. And what's really, really interesting is that we can start to reconstruct how Maori and Polynesians moved through the Pacific through time by looking at these DNA differences. So we started looking, for example, at the DNA from a very early site called Wairau Bar that's located at the top of the South Island, right near Blenheim, out on a sandbar called the Wairau Bar. So this is Wairau Bar. Here's the archaeological site here. This is one of the earliest and most important archaeological sites in New Zealand, and we find the remains of more than 45 people buried at this site that are dated to about 750 years ago. And we've been able to look at the DNA of those individuals, and what we found is that they have all of the diversity, or most of the diversity that we see in Maori and Polynesians today. And so this means that basically it wasn't a single canoe of people who came over and landed on the shores of Aotearoa, but we see many, many hundreds of people who would have arrived here to set up the founding population. So we often have this vision or this image of a canoe of starving people arriving, but actually these people were probably going back and forth and home and bringing new people out, so that we have a very large founding population in Aotearoa in that initial period of Polynesian Maori settlement. But of course, many people have come over time since the Maori arrived. In the 1700s, of course, we had Cook arriving, but we also had Spanish, Dutch, and French, as well as the English, the Germans, and the American whalers and sailors and explorers and sealers. Then we had miners coming from China and from various places around the world, gum diggers, and in the 1960s, many Pacific Islanders coming to work in New Zealand. So we now have this incredibly diverse population as a result of all of these people coming to New Zealand to make better lives for themselves and their children. So this really made us start thinking about, can we study that variation that we see? How do we define ourselves as New Zealanders? We've taken the longest journey. We all have our roots in Africa and through our ancestors, and ultimately we're all here in Aotearoa today. And so many, many interesting journeys that people have been taking. And so we've been studying the deep ancestry of New Zealanders for the last few years. We looked at the DNA, the mitochondrial DNA of the former Governor General, Sir Jerry Aotearoa, and he's got this wonderful Maori Polynesian Pacific heritage, and we see that in his DNA, and that he has very clear Maori mitochondrial DNA belonging to a lineage we call B4A1A1. And we can ultimately trace that back to East Asia, and then ultimately we can trace those East Asian populations back to our shared common ancestry in Africa. Of course, large percentage of the population today is British and traces their ancestry kind of most recently back to the British Isles, and so we see a number of different lineages. For example, about 50% of Western Europeans, including 50% of the people ultimately from Britain, have lineages that belong to the H branch, and then others that we see typically belong to the J's, the T's, the U's, the K's, and the W's. Those are typical European lineages that we see in the British population. And we can see what do we see in the population today. We see other lineages that are typical of Asian populations and lineages that are typical of Pacific populations. So we're reconstructing this evolutionary history. So by taking DNA samples from over 2,000 New Zealanders, we're now reconstructing what the different cities look like and how similar and different they are, and how does that contribute to our overall New Zealand genetic makeup. And we see Dunedin, Wellington, and Christchurch all look very, very similar. And they actually look mostly British with the H's and the J's and the T's and the U's. We see about 6% of the Dunedin population carry the Pacific Polynesian B lineages. We see in Maori and Pacific populations, 7% for Wellington, and slightly less in Christchurch, but overall they all look fairly similar. When we sampled in the North Island, in Hamilton and Auckland, we see quite a different picture compared to, for example, Wellington. Much higher percentage of Maori and Pacific lineages in Auckland and Hamilton, and then the rest of them are kind of European lineages. Interestingly, the African lineages here in L in Auckland. When we started breaking down the Auckland regions, because Auckland's such a big and diverse population, we see quite a lot of difference between different populations. For example, Gisborne, not surprisingly, 65% haplogroup B, which are the Maori and Pacific lineages, compared to Auckland and Wellington. So what we actually see when we look at the DNA across New Zealand is that we actually have almost all of the major mitochondrial lineages in our New Zealand population. So while the Maori were the first to arrive here, we have people coming from across the globe, and we all carry that history in our DNA. So New Zealand is really made up of many people who have taken many, many journeys, and yet we are all New Zealanders today. So I think that's a really important conversation starter that we can all talk about and appreciate both our diverse histories, but also our recent shared common ancestry, so that we're all very recently related. So much to think about. So thank you very much for watching, and I hope you enjoy the rest of your studies about human variation, human diversity.